All right, so we're trying to do 8.5 number 3, where we have y double prime minus 2y prime is 4 for t's between 0 and 1, and 6 between t's, or after t's bigger than 1. And then I have furthermore some initial conditions. I have y at 0 is negative 6. And y prime at 0 is 1. Okay, so first things first, I need to rephrase this in terms of unit step functions. So I'm saying I have y double prime minus 2y prime is, and then what function is on at 0?
4.
Good. And I have a small typo here. I don't know if anybody sees it, but
it's greater than or equal to 1 on both of them, or it's both.
Yeah.
Equal to 1, and you can't have it both equal to 1.
Yep. So there we go. All right. Fixed. All right. So it's 4 at time 0, and then when does it change, and what does it change to? How about let's settle for when does it change?
Changes at 1.
Okay, so I have plus at time 1, so plus u of t minus 1. So that's saying at time 1, something turns on. And the thing that turns on is 6. And the thing that turns off is 4. And 6 minus 4 is 2.
Wow, look at us, we're so smart.
So mathy.
And so I should be able to put a 2 in here instead. Right, that's like saying at time 1, I'm going to turn 2 more on. Okay, now I need to Laplace transform this whole thing. And so I'm going to have s squared y minus, and if you don't have these lines on your Laplace sheet, make sure you put them on there. So the Laplace transform of y double prime is s squared capital Y minus y prime at 0 minus s y at 0. And then I have minus 2, and then this is going to be times y prime, and its Laplace transform is s capital Y minus y at 0. And that's supposed to equal, and on the other side I have a Laplace transform of 4 is 4 over s. And then I need to Laplace transform u of t minus 1 times 2. And the way I do that is I look on the back page here, and on the back page it says that u of t minus tau times f of t corresponds to e to the minus tau s, and then the Laplace transform of f at t plus tau. And I'm running out of room just a little bit. At t plus tau. Everybody with me on that?
Mm-hmm.
If that line's not on, like that line's not exactly on the sheet, right? Add that line to your sheet. It'll make your life easier. So then in this case, right, I have, okay, u of t minus tau. So I think if I have u of t minus 1, that tells me that tau is equal to 1, I hope.
1, yes.
And f of t in this case is 2, right?
Oh, because that's, yes, okay.
So then I have e to the minus s. And then I need f of t plus 1. So that's 2 evaluated at t plus 1. Right?
I think so.
And what do you get when you plug t plus 1 in for all the t's in 2?
T plus 1, 2, 1, 3. What do you mean?
There are no t's in 2.
There are no t's in 2. So where do you plug t plus 1?
Tau?
Nowhere?
Nowhere. There are no t's. And so you get 2. Does that make sense? If there were t's, everywhere there was a t, I would put in a t plus 1. But there aren't any t's.
Wouldn't it be 2 over s?
Yeah.
So, yeah, I haven't Laplace transformed it yet, right?
Okay.
So I should have had a Laplace in here. Right. And so, yeah, you're exactly right. When I Laplace transform that crap, I'm going to get a e, oops, that's not a pen, that's an eraser, an e to the minus s times 2 over s.
S cubed?
No.
What?
Why would it be s cubed?
Well, it's 2 times the Laplace of 1 over s. Or 2 times 1, right?
No, it's
just 1
it's the
over
Laplace of 2.
Right, which would be 2 over s.
Yes.
Yeah. I think she
that's any
about the n
integer.
factorial over s
Yeah,
times
yeah, yeah.
to the n plus 1.
Yeah. It's not t to a power.
Okay.
Yeah.
So the other place you could have gotten this one, instead of going through this business is like the kind of more or less the third to the last line. The fourth to the last line on the table is just u of t minus tau turns into e to the minus tau s over s.
Yeah.
Which is exactly this thing, right? I got a constant, and then I have an e to the minus s over s. Okay, now I need to plug in all my initial conditions and collect some like terms. So I think I have s squared capital Y minus 2s capital Y. Right, so that's accounting for this term and that term. And then I have a minus y prime at 0 is 1. And minus s times y at 0, which is minus 6. And plus 2 times, and y at 0 is again minus 6. And this is equal to 4 over s plus 2e to the minus s over s. Pretty good with that?
Mm-hmm.
Okay, and then this thing here. All right, so this guy is minus 12. And so one of the steps I'm going to have to do is add 13 to both sides. That'll cover this and this. And then I'm also going to, let's see, this whole business here is 6s with a plus, right? So I'm going to subtract 6s here. And so my next line is going to be, I have s squared minus 2s times capital Y is going to equal 4 over S plus 2e to the minus S over S plus 13 minus 6S. Everybody good with that?
Mm-hmm.
Okay. What's my next step?
To divide, or to pull out the capital Y. Oh, you already did. Divide it by S squared minus 2S.
Okay.
Y by itself.
So I have capital Y is 4 over S times S minus 2 plus 2e to the minus S over S times S minus 2 plus 13 minus 6S over S times S minus 2.
Yeah.
Okay, and now I claim I have 2 partial fraction decompositions that I have to do off in the margin here.
Yeah.
Yeah, kinda.
Yep.
But the thing is, these
Not so bad.
yeah, these aren't so bad. One of them is really easy. So the 2 that I have to do are essentially 1 over S squared times S minus 2. And that's going to be an A over S plus B over S squared. Oops, that's still panning. Plus C over S minus 2. And so that's going to say 1 is AS times S minus 2 plus B times S minus 2 plus CS
Why is it equal
squared.
to 1? Why is the numerator 1?
Okay, good question. So I had to do it twice. This one's going to be useful for me in 2 spots. The first 2 terms that I have.
Yeah.
And I just want to deal with the constants later. Because they're, in the first case it's 4, and in the second case it's a 2, and then also an e to the minus s.
Mm-hmm.
And if I want to use it twice, it's usually easier for me to get the constants right if I just use 1.
Okay.
I could use 2, but then on the first one I'd have to double it, and then on the second one I wouldn't, and that would get a little weird.
Okay.
So really what I'm doing is I'm kind of thinking about pulling the 4 down front and the 2e to the minus s down front.
Okay.
And then I'll have to multiply them in a little bit.
Got it.
Okay, so let's see. So S is 0 seems like an obvious choice. When I set S is 0, I get 1 is minus 2b. S is 2 seems like an obvious choice. When I set S equal to 2, I get 1 is C times 4. And then it seems like the S squared term is another obvious choice. And the S squared term would give me, oops, I said 1, but it's 0 on the left-hand side, is equal to
A plus C.
A plus C. Perfect. Okay, so that tells me that A is the opposite of C. C here is a quarter. B is minus a half. And so A is minus a quarter. Right?
That was it, S squared plus the...
It's the S squared term.
Okay.
Yeah, so the only sources of S...
I'm sorry, that was a stupid question.
No, not at all.
A plus C equals 0.
Okay. So Then my other partial fraction decomposition I have to do is this 13 minus 6s1, right? And that one I'm just going to do is 13 minus 6s. So I have 13 minus 6s over s times s minus 2. And I'm going to write that as a over s plus b over s minus 2. And so that's going to be 13 minus 6s is a times s minus 2 plus b times s. And so that would be at s is 0, right? That's 13 is a times negative 2. And at s is 2, that's 1 is 2b. Pretty good with this? Yeah. Okay, so I think I got a is minus 13 halves, which feels like a number that means I made an arithmetic mistake. And b is 1 half.
Yeah, that's right.
Sick.
This book has real bad fractions in it.
Yeah, it's not so much the book as it is the topic. Like differential,
the topic has real bad fractions in it.
Yeah, it's just hard to write differential equations problems that have chill numbers throughout. All right, so I think I have y is 4 times.
Where'd you go? There you are.
Sorry, I wandered over to the side. And then I need my numbers, which were, let's see. So a was minus a quarter. So I had minus a quarter times 1 over s plus minus a half times 1 over s squared. Oh god, why am I doing that? Why is that light green? Oops, not the color I want, not the thing I wanted. Okay, let me try writing that again and see if I can not wander off at an angle.
You might want to scooch over to the left a little.
Oh, I see what you meant. Yeah, probably. Solid plan, since this is going to be enormous. I'm having so much trouble with my rectangle. Okay. Alright. Pen. Color black.
Where are you?
Over to the left.
Yeah, I don't know where I'm at.
I'm not sure where he is right now either.
Okay, so let's try this. Let's go y is 4. I'm just going to have to write this on a couple lines because I can't see everything I need. Okay, so a was minus a quarter, right?
Mm-hmm.
And that was the thing on 1 over s's. Plus, b was minus 1 half, and that was the thing on 1 over s squareds. Plus, c was a quarter, and c was the thing on 1 over s minus 2's. Okay, so that's my first term. Then I have plus 2e to the minus s times the same thing. So minus 1 over 4 times 1 over s minus 1 over 2 times 1 over s squared plus 1 over 4 times 1 over s minus 2. And then the third term somehow is the one that's easier. And the third term became minus 13 halves times 1 over s plus 1 half times 1 over s minus 2. Oops, and I'm still kind of wandering here. Okay. Everybody good with this?
Yep.
Okay, so now we just need to simplify a little bit and then maybe combine like terms. So I have y is minus 1 over s minus 2, minus 2 over s squared plus 1 over s minus 2. And then I have a minus 1 over 2, I guess a minus e to the minus s over 2 times 1 over s minus e to the minus s times 1 over s squared plus 1 half e to the minus s 1 over s minus 2, right? And then a minus 13 halves 1 over s plus 1 half 1 over s minus 2. Okay, then some of this stuff is like terms. So let's see, 1 over s's and 1 over s's. I think that can combine to a grand total of minus 15 halves 1 over s. And the 1 over s minus 2's combine to a total of 3 halves 1 over s minus 2's. And then everything else is just kind of off on its own, right? Okay, so I think I need to rewrite that whole mess, which is kind of sad because it's kind of icky. All right, so all told here, I have a capital Y is a minus 15 halves times 1 over s minus 2 over s squared plus 3 halves times 1 over s minus 2. And then I have all my terms with e's in them. So I have a minus e to the minus s over 2 times 1 over s minus an e to the minus s 1 over s squared and a 1 half e to the minus s times 1 over s minus 2. You guys good with that?
Yeah.
Okay. So then I need to inverse Laplace transform all this stuff. So the 1 over s, I look at that and I think to myself, that's the Laplace transform of 1, right? You guys all with me on that?
Yes.
Okay. Where do you get a s squared on the bottom?
T.
Okay, so that's a t to the what power?
1.
1? And then what should I see on top?
1 factorial over s.
Okay, so I'm seeing that this is going to need to come out front, and then this will be just a t by itself.
Right.
Right? So I'll have a minus 2t out of that whole term. You guys with me on that? How about this 1 over s minus 2? Where do things like that come from?
In the AT.
E to the AT.
Okay, so that comes from an e to the...
2t.
Perfect. And it's positive 2t?
Yes.
Yep.
Why is it positive 2t?
Because the formula is negative s.
Yeah, because the minus sign's built into the
Negative A.
formula, right?
Yeah.
Okay.
Which is 1 over s minus a.
Yep.
Yeah.
So looking at the next 3 terms, what do you see there?
Same thing.
Yeah, those are all the same thing, except now they all have an e to the minus s on them, right? You guys all see that? And so I'm looking at this on the back page here. I'm looking at this line that says u of t minus tau times f of t minus tau corresponds to e to the minus tau s times f of s. So that's saying, look, if you recognize the Laplace transform of something, all you need to do is replace the t's with t minus taus in it, and you can just use the same thing. Does that kind of make sense?
Vaguely.
Okay, so let me show you the execution. So as I go through this, I'm just going to do the first 3 because they're chill. So I'm doing y of t now, right? I'm back in the original place that I was answering questions about. So I have minus 15 halves times 1. Everybody good with that? Okay, hearing none. Then I have minus 2 times t. And then I have plus 3 halves e to the 2t. Okay, and then I have a minus 1/2, right? That's just the constant. And then I have a u at t minus 1. And then I'm thinking, all right, this thing was f of t is 1, right? The thing that you Laplace transform to get 1 over s is 1. And so here I should have 1 evaluated at t minus 1. And we'll come back to that. Well, okay, we can answer that one now. So you need to plug t minus 1 in for all the t's in the formula f of t equals 1. So what do you get?
1.
Good. There are no t's. Plugging it in should be easy. So I get 1. Okay, now the next one, I get a minus u of t minus 1. And then in this case, I'm thinking about, for this one, f of t is t, right? And so now I should have t evaluated at t minus 1. And that's more complicated, right? So I'm just going to leave it like that for a second. And then in my last one, I have 1/2 u of t minus 1. And then what's the function for that one?
e to the 2t.
Good. So that's f of... Okay, so that's f of t is e to the 2t. So I have e, damn it. I have an e to the, drives me insane. I don't know why I can't write on one portion of my screen. Okay, so I have e to the 2t evaluated at t minus 1. Okay, so now for full-on final rewrites. I have y of t is minus 15/2 minus 2t plus 3e to the 2t over 2 minus 1/2 u of t minus 1 minus u of t minus 1 times, okay, so now what's t evaluated at t minus 1?
T?
No.
T minus 1.
Good. You need to plug in t minus 1 for all the t's. And so you have a t, and that t becomes t minus 1. And then I have plus 1/2 u of t minus 1. And now you have e to the
T minus 1 times 2.
good. So that would be 2t minus 2. You guys with me on that? You need to multiply t times, or 2 times all of t. And in this case, we're plugging in t minus 1 for t. So that t gets parentheses around it. Does that make sense?
Mm-hmm.
Cool. Big circle. Call it a day. If we wanted to observe something about this, we might notice that there's some kind of stuff we could have probably guessed from the beginning. From the beginning, I had let's see, I had y double prime minus 2y. Right? Y double prime minus 2y prime. And my expectation of the homogeneous version of this equation was setting this equal to 0, right? So I'd get r squared minus 2r is 0. So r is 0 or r is positive 2, right? Guys with me?
Yeah.
Okay, so my homogeneous solutions, right, should look like a e to the 2t plus b e to the 0t, right?
T?
What's that?
E to the heart t?
Yeah, exactly. It looks even more like a heart in red. So e to the 0t is just 1, right? So that second term is just a constant anyway. So here's your homogeneous solution.
Oh, so A is 3 halves, and B is -15 halves.
Well, yeah, so given those initial conditions, and then I also have some forcing terms, right?
Yeah.
So if I think about the kind of at state 0, right? Like near 0, I have y double prime minus 2y prime equals 4. And so if I did method of undetermined coefficients to that thing, I would kind of think to myself, okay, so to get a constant, I should guess a constant. But that's one of my homogeneous things, so I should guess, right, like for my y particular, I'd be guessing a number, call it A, but then I'd need, A is one of these, right? It's actually B in that case, but so I'd need to slap a T on it. Okay, that's this guy.
Yeah, right.
Right, that's the particular solution. These two are the homogeneous solution. And then the rest of this junk, where did all that crap come from?
The piecewise stuff.
Yeah, that stuff all starts at time 1, right? Everything in there has got a u of t minus 1. So all that stuff doesn't even happen until time 1. And the reason it doesn't happen until time 1 is that external force doesn't change until time 1. You guys kind of see that?
Yeah.
Yeah.
Okay, so you can usually eyeball some of this stuff. This is not, this technique doesn't yield different thoughts than our previous stuff. It just deals with discontinuous functions, and our previous stuff wouldn't. Does that kind of make sense? We could try to set this up so that we could have used the previous techniques, but I really have fundamental issues with that discontinuous stuff with our previous thoughts. But the Laplace transform just doesn't care. So it's kind of a crazy tool because it just doesn't really worry that much about discontinuity, which is kind of weird. But discontinuity of like forcing functions happens all the time in real life. You can see it if you go to the Exploratorium all over the place. There's all sorts of these little like spring things that they have where you flip a switch and it turns on an electromagnetic field, and then everything starts behaving differently. And that's exactly what's going on here, right? It's got some forcing term like gravity, and then we flip a switch and then the forcing term changes. You guys kind of with me on that?
Yeah.
Okay. Questions on this?